So good evening everyone. My name is Manish and in this class we're going to learn about combination of resistor. Till now we have studied that an electric current will pass through a circuit when we connect a battery through it, right? And if there is a resistor as well. So in this class we will learn about like what we or how we will approach a question which will be having more than one resistor. Okay. So there are two types of combination of resistor which can be possible in our circuits. One is series combination and another is parallel combination. So when current through each resistor is same, when current through each resistor is same and in points are not connected, then it is in series combination. It is said to be in series combination. Okay. So one thing which I will tell you that when current through each resistor is same, it doesn't mean that it will always in series combination for sure. Okay. One must have to satisfy that the resistance current in both the resistance is same as well as their end points are not connected. Let us say example, like let's say this is a register of resistance R and another of register of resistance R. So if we connect battery across it, still they both have same value of current. Still they are not in series. So that means current should be same as well as their end points should not connected to each other. That will be the complete definition of resistor in the series. Okay. So now we're going to learn that how we will solve if we get these kind of combination, like these three are in series, these three are also in series. So let us say if these three are or these two are or these n are in series, then how we will approach the question. This is the first question. Second question is that we have learned till now the Kirchhoff's loop law and Kirchhoff's junction law. So we can use Kirchhoff's loop law over here. According to Kirchhoff's loop law, total sum of potential difference across entire loop, the sum of that potential differences will be equal to zero, right? This law, we will get the result that the R equivalent, the net equivalent resistance of this circuit will be nothing but R1 plus R2. And in similar manner, in this resistance, in this circuit, R equivalent will be nothing but R1 plus R2 plus R3. And again in this circuit, it will be R1 plus R2 plus R3. Okay. Now we are moving to the next part where we have n register which is having resistance of R. So over here it will be nothing but R plus R plus R plus R plus n times, right? So it will be nothing but n times of R, right? So in series combination, it is very simple to calculate what is the R equivalent. It will be nothing but the sum of the all resistors, all the resistances of the entire resistors. Okay. So whenever you are getting the question from series combination, first of all identify whether it is in series combination or not. If you have identified that it is in series combination, then just do one thing. Do what? Just add them. You will get the entire value of equivalent resistance. Okay. So now let us move to the next part, which is parallel combination. So in parallel combination, there is still a two condition. One is when potential difference across resistor are same, but it is not only the sufficient condition. Another is end points are connected or end point are meeting. Okay. So if it is the case, then what will happen? These two will be in the parallel combination. Okay. So if it is parallel in parallel combination, R equivalent of these two, we will get this from Kirchhoff's loop law and junction law, that it will be nothing but R1 R2 R1 into R2 divided by R1 plus R2, or in general we equivalent, which is R1 upon R equivalent, will be nothing but 1 upon R1 plus 1 upon R2 plus like this. if it is the circuit which is having more than one register. Okay, so if let us say assume a scenario like previous one, like if we have a circuit which is having an identical register, and identical means that each register having same resistance. So what will happen, we will get 1 upon R equivalent, which will be nothing but 1 upon R plus 1 upon R plus n times, right? So from here we can take 1 upon R common, then it will be nothing but 1 plus 1 n times, that means n. So 1 upon R equivalent will be nothing but n upon R. So from here we will get that R equivalent will be R upon n, correct? So we can write over here RA will be nothing but R upon n. Okay. So now let us move to the next part. So we get two results from here, right? In series combination, R equivalent will be nothing but R1 plus R2 plus R3 plus R4 plus R5 and so on and so forth. Combination 1 upon R equivalent will be nothing but 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on and so forth. Okay. Now we are moving to the next part. I am keeping this part for you to solve this question. What will be RAB if this is the case? Okay. Now let us move to the this question. So over here, the question says that two resistors when connected in series, their effective resistance is 10 ohm. When both are connected in parallel, their effective resistance is 2.1 ohm. Then the resistors are, so what will be the value of these two resistors which is doing these kind of things, okay, showing this kind of result. So let us assume that one resistor is R1 and another is R2. Okay, so when it is connected in series, when connected in series, then it will have R equivalent, that will be nothing but R1 plus R2. So R equivalent is given over here, which is 10 ohm. So 10 will be equal to R1 plus R2. And when it is connected in parallel, when connected in parallel, when it is connected in parallel, it will be nothing but 1 upon R equivalent will be 1 by R1 plus 1 by R2. From here we get that R equivalent is R1 into R1 divided by R1 plus R2, and which is uh, 2.1 in this case. We can put R1 plus R2 as a 10 from this equation. Let us say this is equation number 1. So we will get the value of R1 into R2 by 10 is equal to 2.1. That means R1 into R2 will be 21 ohm, right? So by solving this equation, it is obvious that one of them will be 3 and one of them will be 7, because R3 plus 7 will be 10 and 3 into 7 will be 21. So we can write R1 which will be equal to 7 ohm and R2 which will be 3 ohm and vice versa. Otherwise R1 will be 3 and R2 will be 7. Okay. So now let us move to the next part. And in this question, we have a circuit which is given over here, and another condition is that resistances of each resistor are same, that means these resistors are identical. So by looking into these types of circuit, we don't know whether it is in parallel or in series. First of all, we need to arrange them in the simple manner. In simple manner means that we can identify by seeing the circuit itself that whether it is in series or whether it is in parallel. So first of all, we will name these common junctions where all the resistors are meeting. So let us say this point is C and this point is D. Now we are pointing this as A, this as a B, and we need to find resistances equivalent between RA to B. That means RAB. And let us put this point as a C and this point as a D. So one resistor which is and one more thing is that A and D are connected through a, you know, a wire which is having no resistance. That means potential at A and D are same. That means we can join A and D together. Okay, I hope you got it. So we can write A and D point at same point because potential at A and D are same. So that means we can write this as a D point as well. Now A and C are connected through a resistor. So let us connect that. And C and D are also connected through a resistor, and C and D and A coincide. So this will be like this one, right? Again, C and B are connected through a resistor of resistance R. And D and B, D is over here, so it is connected through B. Each resistor having resistance of R ohm. So that means it is R, it is R, it is R, and it is R. We can say that we can see that these two are in parallel. That means R equivalent will be nothing but R1 into R2 divided by R plus R. That means R square by 2R. That means R by 2. And from here we will get that this entire circuit is in series with this resistor. So what will be the R equivalent of the upper part? It will be nothing but R by 2 plus R. That means 3R by 2. And the lower part is R. Now these entire combination of resistors are in parallel with this resistor. So what will be the R equivalent or RAB? That will be nothing but R1 into R2. So R1 is 3R by 2 into R2 is R divided by 3R by 2 plus R. So it will be nothing but 3R square by 2, and it is 3R plus 2R 5R. So 5R divided by 2. So 2 and 2 will be cancelled out. From here we will get RAB, that will be an R and 1R will be cancelled out. And this will be 3R by 5. Okay. So thank you for attending the class. We're going to learn the next topics in the upcoming class.